Hi guys, time for the Chapter 3 lecture, and so we're going to go ahead and get started. I'm going to make this one short and sweet as possible. It's fairly simple. Basically, we're looking at addressing and ports and some other things that help us configure a computer to be on a network. So it should not take long. I'm not going to be tedious about it. Let's go ahead, go to the desktop, and get started. Okay, so we're looking at uh, the slides for Module 3, and you need to follow along, read these slides more carefully than what I'm going to, because I'm going to go through them quickly. Also, don't forget, you are responsible for reading the material out of the chapter. I'm not going to go into detail here. I'm just going to kind of skip over, gloss over, and hit the high points to point some things out to you, but very important that you read the chapter, because as much as you're responsible for the notes, you're also responsible for the reading material. Let's get started. Okay, once again, like we always do, module objectives. This is what you should know at the end of this module. You should know what a MAC address is and how to work with it. You should know how to configure a Windows computer, at least for TCP/IP settings. That would be the IP address, subnet mask, default gateway, and DNS server. So you should know how to be able to put a Windows PC on a network using both static IPs and DHCP. Identify the ports for several common network protocols. FTP is port 21. Port 80 is an old port for HTTP, things like that. Describe domain names, Microsoft.com. You should know how a DNS server works. And finally, use command line tools like traceroute to troubleshoot common network problems. Okay, so there's 4 kinds of addressing. You need to know that. You need to know the difference between MAC address, IP address, port numbers, and fully qualified domain names. And then this kind of goes through and explains what's going on. And you need to know the difference between IPv4 and v6. You need to know what they look like. You need to know how to interpret them. You need to know what part is host and what part is network for each of those different kinds of addresses. The bits will tell you. You need to know about network address translation, how to use router, or how a router translates incoming messages with a public IP into local IP addresses, because you know that not every computer gets a public IP address, because we're out of them. IPv6, you need to know what they look like. You need to know when you can use two sets of colons to represent a double set of zeros. And you need to know the vocabulary. You need to know the 4 types of IPv6 addresses, what a global address does, what a link local does, what a loopback does, difference between unicast and multicast, and anycast. And there again, talk about what part of the address belongs to the network and what part belongs to the host. You need to know the command for bringing up your IP information on a computer, whether it's a Windows computer with ipconfig or whether it's a Linux computer with IF, whatever type of computer you're working on, you do need to know how to pull up the network information. Which of the following is a public IP address? You need to know which of these 4 is public. I'll tell you right now, that's a Class A private, that's a Class B private, that's a Class C private. That is a public address. You could route that on the internet, and you could get that from your ISP. These you would get from a local router behind a firewall. And like I said, all those other ones were private RFC 1918s. Ports and sockets, you need to know there's some common applications. We're going to talk about FTP is, like I said a while ago, 21. The mail port, SMTP is 25. These are old values. Nowadays they use IMAP and they use secured ports, which are different numbers. Also 80 and 8080, 8080, both of those are HTTP. But like I said, these are older numbers, so you'll need to know the ones that are in your book. And basically what a port does, it allows a router to not only pick out a specific computer to send a message to, but a specific application on that computer. So like if I want to send an FTP message to a computer on my network, if I want to hit the FTP server, and let's say the IP address is 10.0.0.5, then what I would do is I would route the message 10.0.0.5:21, and that would send the message specifically to the FTP server, and then the computer would know what to do with it. It would know what application to use to open that message or to perform whatever commands I sent. Domain names, you should be familiar with those already. Microsoft.com, Grayson.edu, different names. You need to know about the Internet Naming Authority and the type of hosts. ARPA. Nobody uses ARPA anymore. That was the original ARPANET back in the day, back in the 70s, and nobody does that anymore. The military uses .mil. Schools and educational facilities .edu. The government uses .gov. These are all restricted to specific organizations. And then, of course, .com, .net. Now they got .tv and a lot of other different ones. Those are pretty much unrestricted. Anybody can buy a domain name with those prefixes. You need to know about DNS, domain name servers, and how they work. You need to know the process. So your web server goes out, it talks to another web server, or your client rather goes out and talks to another web server, and it wants to go to Microsoft.com. Well, the computer has no concept of what Microsoft.com is. They're not so good with English language, but they are really good with numbers. And so that web server goes to the DNS server and says, hey, Microsoft.com, what is that? And then the DNS server looks at the database and goes through the list and says, oh, Microsoft.com, well, that's 69.124.8.47 or whatever. Sends that information back to the web server, and the web server says, oh, okay, you mean you really want to go to this IP address? And your computer says yes. So the web server connects you to that web server that has that IP address, and now you're talking to Microsoft.com. So you need to know how DNS servers work. You need to know what resolvers, what the actual name servers are, and what namespace means. Basically, DNS is just a database. That's all it is. It's a distributed database, which means it's scattered out over a lot of servers. It's not just on one server. So if one of the main DNS servers goes down, that's okay, because others are redundant, and they will take over the load until that DNS server comes back up. Primary and secondary, you need to know the difference. When you look at your IP information, you'll find that your computer has a space for 2 DNS servers. Caching DNS servers and forwarding, you need to know the difference there. Let's see here. You need to know exactly how a resolution. Some DNS servers require an answer and some don't. Some can forward your request onto another. And you need to know the difference. You need to know about recursive. That demands a resolution. Even if the answer is it can't be found, it's not out there. Iterative, on the other hand, says a local DNS server can forward it to another, it may or may not have an answer. You need to know the different kinds of records that DNS server stores: start of authority, A records, quadruple A records, canonical or CNAME records, pointers, name server records, mail exchange records. All those different types of records are in the DNS server, in the DNS database. The 3 different kinds of software that DNS servers use: Bind, probably the most popular. Microsoft DNS, if you're on a purely Windows environment internally, then you're using Microsoft DNS because it's built into the Microsoft domain controllers and servers, so it's a lot easier to use Microsoft DNS server. Windows Server is capable of split these are, you don't need to know what that means particularly, but you just need to know that it can handle internal and external clients both. Troubleshooting problems. Here we go. So these are some command line tools. Remember we talked about in Module 3 a little earlier, we talked about, or you will you may or may not have read the video or watched the video yet, but there's a video that tells you how to export results to a text file. Starting now, you're going to start having to consider that, because you're going to be turning in some of these results. You need to turn them as a text file. So ping, Packet Internet Groper is the first tool that we're going to look at. It comes with Windows. It comes as a command line utility with all Windows installation. And basically what it does is it allows you to determine if there's something out there on the network with that IP address. You can ping an IP address and you'll get a response. And based on the response you get and also the amount of time you get, basically you're just sending out an echo request. And so it sends back a request with the information you asked for. That will tell you if that particular IP address is active on the network. Uses the ICMP protocol, and that's the rules that regulate pings. What that rule does basically is it tells you that the things you can get with a ping and the things you can't. It also prevents pings from being malformed into a weapon. Used to you could turn a ping into a weapon, but as the protocols have been modified, your computer won't respond to those malformed ping requests anymore. And of course, there's ICMP v6 for networks that use a v6 network addresses. ipconfig, we've already looked at that one a couple of times. Basically, ipconfig will give you the DNS, the IP address, and the net mask for your computer. If you put in the all tag, ipconfig/all, then that will give you the IP information for every adapter on your computer, including Bluetooth, including every possible network connection, wireless or wired, or even the ones that come in with like tunneling addresses. Okay, let's see. IP utilities. This is Linux, so you're looking at now a Linux command. ifconfig is similar to the ipconfig on your Windows computer. So if you're using Linux or Unix, you'll just, instead of typing ipconfig, type in ifconfig, and that will give you the same kind of information. Namespace lookup allows you to query DNS databases, so you can talk to a DNS database directly to see what a host's IP address is. Or reverse lookup, you can type in nslookup with an IP address and it will return to you the fully qualified domain name. So that is a very useful tool. Domain information groper is basically what a ping is for Linux and Mac. So this allows you to look up more information on DNS servers from a Linux or a Mac computer, just like nslookup allows you to use it on Windows computers. IP scanner will go out and query the entire network that you're on, and it will return a response for every IP address, and usually it's combined with a port scanner, so it'll return port information also for any computers that happen to be on your network. Let me right now save you a lot of heartache and a lot of trouble. If you are using, and we will be using a little bit later, we'll be using port scanners and IP scanners in this class. Do not run them on the school's network. Do not go to the library or in your dorm room, get on the Wi-Fi and run one of these scanners. What will happen is, because they are seen as malware attacks, the IP guys will easily know exactly who ran it, and they will shut your internet access off. And then you'll get to go up and explain to them what you're doing and ask them very nicely, and maybe they'll put you back on the network. So don't run these tools on the open network at the school. Come to the classroom. If you can't run this at home, come to the classroom and you can run it here on our closed network. We have two different colored network cables. Well, one of them is open and connects to the internet and the school network, etc., and the other one is just interior to the room. that's what you're going to want to run this on. You do not run these diagnostic tools on open networks. Also, if you're running them at home, don't run them with your router plugged into the internet. Run them within your internal network, but don't try to port scan. Number one, it would take a long time. Number two, your ISP is going to turn off your internet access if you do that, because they think you're trying to set up some kind of a malware attack. If you're just madly pinging all the nodes on on your ISP's network, they're going to shut you off and probably not going to turn you back on anytime soon. So don't do that. When you run these tools, run them in this classroom, run them on the network here that is isolated, or at home, run them on just your internal network. Just unplug your the incoming network cable, and then you'll be fine. Common network issues: incorrect time. If your time and the server time don't match up, the server will not let you on a network. That happens usually, kind of a troubleshooting tip here, that happens usually when the client's motherboard battery, a little watch battery on your motherboard that keeps your BIOS alive, the BIOS battery, when that dies, your clock goes crazy. When you turn your computer off, then the clock does not continue to get power, and it dies. And so when you turn your computer back on, then your clock says something like 12 midnight on April 16th of 1983 or some peculiar date like that. Well, then when you try to get on the network, you'll find that you cannot get on to the internet because your clock and the clock on the web server don't match up. So that's always a good thing to check when you can't get on the internet. You can't figure out why. DHCP issues, if you're getting, the most common one there is multiple clients having the same IP address. DHCP is a dynamic way of assigning IP addresses. What can happen, though, is if you've got an IP address that's been leased to a computer that's been off the internet or off the network for a while, and that IP address is given to another computer, or somebody is assigned a static IP that's in your DHCP pool, then what's going to happen is both those computers are going to get a little message that says duplicate IPs on the network, and neither one of them will be able to connect. So DHCP issues, a lot of times that's going to be a duplicate. So make sure, number one, that you don't assign static IPs anywhere close to your DHCP pool, and number two, be aware of your lease time. We'll talk about leases a little bit later, but be aware of the lease time for your IP addresses. Common configuration issues: you mistyped an IP address, you mistyped a subnet mask, you mistyped DNS. That happens a lot. You always want to do that. Fortunately, Windows checks before, when you're adding an IP address statically, it will click the OK button to confirm your changes. It will check and make sure that you can get on the internet that you're trying to get on, or the network you're trying to get on. And if it can't, it will tell you something's wrong there. So if the static settings have the wrong information, you're not going to be able to get on. If you still can't get on and you're sure you have the right information, just click the DHCP dot and tell it OK, and it will go ahead and get a dynamic IP address. That will tell you if you've got a hardware issue of some kind. Maybe your cable's bad. Protocols, which one does it use? For ping, not web protocol, not DHCP for IP addresses, not FTP for file transfer. It uses ICMP. And so that's the protocol that allows you to send pings out. All right, so our module summary. You should be able to work with MAC addresses. You should know the physical address of a network adapter called the MAC address. You should be able to configure TCP/IP settings. You should be able to identify ports like 21 for FTP, 80 for the web, and things like that. You should be able to describe a domain name and also understand how a DNS server works. And finally, there's some command line tools that you need to know. So that basically covers Module 3. So we've looked at Module 3, and that's what it does. Like I said, I'm trying to keep these videos from running long. I know that you've got things to do, but I want to hit the high points at least and kind of give you an idea of the things that you need to be familiar with for the class. So now you can go ahead and move on to the chapter quiz, and I will see you guys on Thursday night in class. Have a good day, and let me know, please, if you have any questions.